Alright, so I suppose now would be a good time to kind of go back through this.
Quantum mechanics has lots of weird stuff, but there's one thing that everyone
This is
agrees
very weird.
that no one understands.
Okay, well,
I'm talking about quantum spin.
back to our little snowflake
Let's
here.
find out how chasing this elusive
We're going to
little
use this as a
behavior
particle.
electron
We're also going to use
led
it
us to
like an
some of the
electron.
deepest
We're also going to use it
insights
like
into
you.
the
You
nature
don't
of the quantum
fractal
world.
well. You have CT paradoxes. And like on Earth, we have an
There's a
abundancy.
classic demonstration done in undergraduate physics courses.
Now,
The
like
physics professor sits
this
on a
classic
swivel stool
example.
and holds a spinning bicycle wheel. They flip the wheel over and suddenly begin to rotate on the stool. It's a demonstration of the conservation of angular momentum. The angular momentum
If
of
you
the
were a
wheel
teacher
is changed in one direction,
and
so the
you
angular
had the
momentum
script
of
flipped
the
on you,
professor has
you'd
to
be spinning
increase in the
around
other
in your chair
direction
about
to
with
leave the
students
total
how
angular
that angular
is the same.
momentum
Believe it or
in
not,
the field of a
this
simple
is
triangulation.
basically the same
Very
experiment.
simple. We get to
Suspend
here.
a cylinder of iron from a thread.
Okay, this piece of dynamite that you got. All right. So atomically, the particle, the atomic structure, has some systems inside here. We are not looking at hydrogen 0, 1 orders of operations like it's necessarily this type of spin. See, it's got this, that I1, I1, I2, I2 type of way about it, where I don't necessarily know that yet. And even if I did know it, how that correlates in recombination and acceleration later on to what I'm talking about by Planck's constant material. When you look at the black body radiation, or excuse me, the triple point of any element on that periodic table, basically you're still going to have some form of X or Y in there. Now, they're probably half by virtue, but thirds is a closer distance, and that'll add most its way down. Iron is in that order of operations where we are going to utilize magnets because next to each other, the decay state still have charges. This isn't really spinning, and there's an electron shell to it that's all kind of taking place on one of these 10 surfaces. What did I say, 10? How did you get 10 out of this? Well, you got 8 edges because there's 2 sides. In the center of those, we do have an ability of a measurement that is this plus or minus. What that's going to be after you pass the midpoint. And so it connects, and there's going to be certain materials that are within the bandwidth, the photochemistry. If you're going to use not an XRF gun, it's actually a spectrum gun to determine light's emission, because if you put enough power through it, it's going to become a conductor. Sodium, I think, burns orange. Zinc burns purple or blue, something like that. And that's a chemical X. That is a marker to say, because light, because voltage, because of the way it changes its triple point, with these things, that is to say, mathematically, you could make that distinguishing that is from spectrometry. And with that, I can get a very, very strong resonance. Now,
and switch on
they're not going to be
vertical magnetic
perfect.
field. The cylinder immediately starts rotating.
They'll line
with
up a
constant
magnetic
speed.
field, but it's still
At
the
first
material.
glance, this appears to violate
was it
conservation of angular
tempered?
momentum
Did
there was nothing
like
spinning to start with.
steel?
Except
You
it
heat
was.
it
Or at least
oxidizes,
there
drops
sort of
off.
was.
It follows the black
external
body
magnetic
problem. You can
field
keep doing that
magnetized the
as long
iron,
as we're very
causing the
consistent
electrons in the
about
iron's
heat,
outer shells to
oxidize,
align their spins.
grind,
Those electrons are
heat,
acting like
oxidize,
tiny
grind,
bicycle
and you'd always
wheels,
lose that.
And the shifted angular momenta
The
is
longer,
compensated
if it was
by
just set
rotating
into
cylinder.
a furnace,
That explanation makes
the
sense
time
if we
amount
imagine the
about it being
electrons
there
like
is not really
spinning bicycle
practical.
wheels,
It's not on one of the
like
scale
spinning
measurements
anything,
that just heat
which might sound
abundantly
fine because
forever in
electrons
that
do have
angular
this property that
momentum
we call spin.
is going to
But
do
there's a huge problem.
much more
Electrons are
than heat
definitely
the outside
not
of it. The
spinning
outside
like
gets
bicycle
oxidized,
wheels,
but it
and yet they do seem to
protects
possess a
itself.
very strange
Silver
type
oxide
of
on the
angular
surface,
momentum that somehow
sodium
exists
oxide
without
around it.
classical rotation.
They like
In
to
fact,
link up
the spin of the electron is far more
a little
fundamental
differently,
than simple
but once
rotation.
that's all
It's
in
a
its
quantum
atomic
property of
shell
particles,
take care of,
like mass
it's going
or
to take a little
various
bit more.
charges.
It's going to take
But it doesn't just cause magnets to move in
drilling the
funny
aluminum
ways.
and breaking
turns
through
out
the
that quantum
oxide
spin is a
surface before
manifestation
sodium
of a much
is going to
deeper
really have
property
that
of
effect
particles, a
on
property that is responsible for the structure
aluminum like
of
that,
all
because
matter.
it doesn't
We'll
affect
unravel
in
all
the
of that
structure
over a couple
of
episodes, but today
aluminum
we're gonna talk about
oxide.
what spin
Now,
really is, and
mathematically,
get a little
you
closer
think
to
about the
understanding
triangulations
this
and
weird
why
property
it
of nature.
should, why it shouldn't,
The
why it can
experiment with
pass
the
through
ion
that
cylinder is
barrier
called the
when they're talking
Einstein-de
about
Haas
particles that
effect.
can
First performed
pass
by,
through solid
Einstein
material.
and de Haas in
There might be a
1915.
timeline to it.
It wasn't
There
the
might be
first
an
indication
endo
of the
or
spin-like properties of
exo or
electrons.
endothermic
That came
reaction
from
to
looking
it.
at the specific
The
wavelengths
heat
of
that
photons
it
that
emits
between
is
electrons
something we
jump
can't really
between
see. It's
energy
not really
level
emitting
atoms.
heat.
Peter
But
Zeeman,
it would,
working with the
mathematically,
great
if I saw
Heinrich
smoke,
Lorentz in the
I'd assume
Netherlands,
fire.
found that
If it was
these
raging
energy
fire
levels tend to
on the black
split
body
when atoms are
radiation,
put in
neutron
an external
star,
magnetic
neutron
field.
star black hole,
This Zeeman
which
effect
how
was
they got
explained
there.
by Lorentz himself,
Massive
with the
gas
ideas of
cloud
classical
collapse,
physics. If you think of
supernova,
an electron as
no
a
nova,
ball of charge
or
moving in a
some
circle
neutron
around
star
the atom,
base where
that motion
it just
leads to a
red dwarf,
magnetic
or
moment,
excuse me,
a
red
dipole magnetic
giant
field
R
like a
star
tiny bar magnet.
after it burns out in
The
its
different
life.
alignments of that orbital
In its
magnetic field
lifespan,
relative to the external field turns one energy
the
level
sun
into
is
three.
much like
Well, sounds reasonable,
this
but then came
this squared
the anomalous
as
Zeeman
far as what
effect.
it does.
In some cases, the magnetic field
Now,
causes energy levels to split even further.
how do we
for
really
reasons
make sure that
were,
it's
at the
square in this
time,
way?
complete mystery. One explanation
Like
that
us,
sort
we'll
of
have
works
two different
is to
measurements.
say that
This
each
is
electron
enough for
has
our
its
range
own
of error,
magnetic
hopefully,
moment.
on those
By
scales.
itself, it acts like
Wouldn't
a
need
tiny
to be
bar
as
magnet.
me
So you
walking
have the
out a
alignment of
mile
both the orbital
in
magnetic moment
inches.
and the electron's
I would need
internal
some
moment
scale,
contributing new
1
energy
to
levels.
100,
But for that to make
where
sense, we really
the
need
log
to think of
wouldn't do
electrons as balls of
centimeters.
spinning
I
charge.
don't know how they got
That has huge
centimeters, what the
problems.
original
For
increment
example,
was.
in order to produce the
Except I
observed
say
magnetic
thumb
moment,
because
they
that's
need to
what
be
one is,
spinning
seems
faster than the
good,
speed of
works
light.
12
This was
inches.
first pointed out by the Austrian physicist
'Cause
Wolfgang Pauli.
12 of
He showed
them
that
is
if you assume
roughly a
electrons
foot.
have the maximum possible
it
size
works well.
given by the best measurements of the day, then their surfaces
When
would
you
have to be moving
fractalize
faster
it
than
on
light to
thirds,
give the
it's
required
certainly
angular
it's going to
momentum.
be
And that's assuming the electrons even have a
three-
size. As
or
far as we know,
33
they are
point-
point-like. They have zero size, which would make the idea of
so
classical
if it
angular
was
momentum even more nonsensical.
3
Pauli rejected the
trying to get
idea of
centimeters here close.
associating such a classical property
At any
like
rate,
rotation
the conversion
to the
still
electron.
happens the same
Instead,
way,
insisting on
except for here
calling
we're
it
doing it on the
classically
fractals or
non-describable
logs
two-valuedness.
of that inch.
Okay. So
Computer's
electrons
not going to do
aren't
this.
spinning,
I
but
need
somehow they act like they have angular
running on
momentum.
log 7,
And
staying
this
in
is how
an
we think
order
about quantum
of
spin now.
log
It's an intrinsic
5.
angular momentum
I would need
that
an
plays into the conservation of
excuse
angular
me, a
momentum,
phase
like in the
of
Einstein-de Haas
5
effect.
that is
And it also
10,
gives electrons that magnetic
15,
field.
20,
An electron's
because otherwise
spin
7
is
won't
an
work in there.
entirely
I need
quantum
something to
mechanical property.
pass that
It has all the
Gaussian
weirdness you'd expect
through
from
that
the
system,
weirdest of theories. But
so that
before
way
we dive
properly
into that weirdness,
1/2
let me
of
give you
this,
one
or
more
the scale of
experiment
that is
reveals
somewhere
the
where it's a
magnetic
shorter
properties
distance
that
where I can
result
get the
from
cat in
spin.
front of that mouse.
This is the Stern-Gerlach experiment, proposed by Otto Stern in 1921
So they don't
and
exactly
performed
spin
by Walter
that way,
Gerlach
but they
a year
will
later.
spin.
In
They
it,
will
silver
create.
atoms
It's
are
still
fired through a
no
magnetic
initial
field
charge
with a
force.
gradient.
Well,
In
space
this example,
expanding
stronger
kind of
towards
does
the
this a
North
little
Pole
bit
above and getting weaker
initially
going
before
down.
we get
A
to
lone electron in the outer shell of the silver
why
atoms
pressure and gravity
grants those atoms a
in
magnetic
super
moment.
spaces like a
That means the
neutron star
external
core
magnetic field induces a force on the atoms
look the way it does
that
because it's
depends on the
counterintuitive,
directions that
right?
these
We would
little
think that
magnetic moments are
we
pointing
would think that the
relative to that
charge
field.
works
Those that are
this
perfectly
way, but it
aligned with
actually
the
works
field will
this
be
way
deflected by the most
given to
either
those
up or
systems.
down.
When
If
in an
these were
area
classical
like
dipole
that,
fields, like
those
actual tiny
tensors
bar magnets, then the
fold
ones that
this
were
in
only
such a
partially
way,
aligned with the
homogenize it,
external
make
field should be
fields
deflected by less.
that
So,
from
a
that
stream
distance of the
silver
core,
atoms with
whether it had
randomly
enough
aligned
acceleration to
magnetic
get out of there,
moments is
started
sent
to
through the magnetic
have too much
field.
friction,
You might
started to
expect
lose
a
that
blur of
friction
points
before
where
it
the
could
silver
start to
atoms
break
hit the
down.
detector screen.
Starts to
Some
happen, and
deflected
that's
up
because
or down
space
by the
in
maximum,
general
but most
works
deflected
like these
somewhere in
fractals.
between
Remember,
due to
one
all the random
hole is a
orientations.
third and a half.
That
It
is
has
not
those
what's
things.
observed.
It could be at a
Instead, the
ratio
atoms
of
hit the screen in
3
only
of
two
these
spots,
is enough to do
corresponding to
the
most
operation that
extreme
I'm trying to do, a
deflections.
3-inch by 3-inch square.
Let's keep going.
We can make
What
that
if we remove the
infinitesimally
screen and bring
long
the beam of atoms
if we
back
did
together?
logs like that.
Now we know
If
that
the
the
fractals were
electrons
square
have to be
instead of
aligned
centimeters
only
like
up
that,
or down.
we could find
Let's
that
send them
at
through
one
a
of those
second
levels, we want the log of that to be a better symmetry, because symmetries are cleaner, easier to understand. They mechanically operate so that way that mere force or that symmetry is conserved by whatever form of the result we had. We're still semi-imperial inside of that. But here we're getting this thing trucking, 0 and 1,
fundamentally quantum.
1 to
The
2
direction
here,
of
these
this
things,
spin
X and
property
Y,
is
A and B,
quantized. It can only take on
function in the
specific
dominion,
values.
can
That direction
overdo
depends on
that
the
limit.
direction in
What
which you
happens in the
choose to
computer,
measure it.
it'll fuzzle
Here
out.
we see an
Too much
example of
voltage, too
Pauli's
much amperage, too much
two-valuedness,
current. It wants to
manifesting
be
as something
here.
like the direction of
And
a
the
rotation
polarization
axis, or the
of that
north-south
system,
pole of the magnetic dipole.
and so whatever they, I'm not
Actually,
really great with the
this
computer work like that, but that's where a lot of the
two-valuedness
video
is far
can
deeper than
run
that.
corruption or
To
whatever.
understand why, we need to see how spin is described in
By
quantum
bits.
mechanics.
I can only have
It
it
was
do
again
so many
Pauli
things and cheat
who
that
had the
system
first
so
big
many ways.
success
If there's
here.
only so many
By
sprites
the
I'm allowed to
mid-1920s,
have on there, it's because
physicists
it's
were
utilizing those
very
bits
excited about a brand
in
new
such a
tool
way
they
that the
given,
Gaussian optics
Schrödinger equation. This equation
gives
describes
it
how quantum
a
objects
super
behave as
determining
evolving distributions
matrix
of
of
probability
in the area
as wave
on world
functions.
engines that
It was
run
proving
speeds.
amazingly
If I
successful at
programmed
describing
any
some
avatar,
aspects of the subatomic
changed its
world,
name,
but the
triangulation,
equation as Schrödinger first
would
conceived
give
it
me
did not include spin.
a system where I
Pauli
could tell
managed
you
to
that
fix this
that is a
by
fair
forcing the wave function to have
conservation
two
information as a
components.
gauge boson to say
Motivated by this
voltage, amps, or
ambiguous
currents are
two-valuedness
acceptable
of
at this
electrons.
level. It's not going to create new
The wave
elements.
function became a very
There
strange
are
mathematical object
reasons
called a
why
spinor, which had
identifying
just
the
been invented
system's
a decade
triple
prior.
point, and it
And
melted
just
there
1 year after Pauli's
at a
discovery,
high yielding
Paul
of
Dirac
mind
found his own even more
to
complete fix of
then
the
tell
Schrödinger
you
equation.
it's more
In this case, to
beneficial
make it work with
by
Einstein's special theory of
ratio
relativity,
to go
something
there
we've
and mine it
discussed
out
before.
because it has a higher
Dirac
probability of
wasn't even
hitting
trying to
that.
incorporate spin, but
If
the
it's
only way
a
the equation
lower
could be
volume
derived was
of
using
uh,
spinors.
atoms in that
Now,
aggregate,
spinors are
but it's a much
exceptionally
larger area
and cool, and really
over
deserve
that
their own
system, it
episode.
would be more beneficial
But
to
let me say a
take
couple
that
of
one
things to
that
give you
one
a
of those
taste.
routes X, Y, Z,
They
T.
describe particles that
It's
have
not exactly
very strange rotation
opposite.
properties. For familiar objects, a rotation
It's
of 360
from
degrees
that
gets it back to its
adjacent
starting point.
or
That's
from
also true of
that
vectors, which are just arrows pointing
hypotenuse's
in some
value.
space.
That's where
But for
it
a
is
spinor,
on
you need to
increments
rotate
of
it
ones that did
twice,
that.
or 720
It would
degrees
no-knock
to get it
fuel
back to its
in its
starting state. Here's an
fractalization.
example of spinor-like behavior. If I
So it's not
rotate
just
this
that
nut
gas
without
fractals.
letting go,
It
my
kind of depends
arm
on
gets
its
a
rig.
twist.
It kind of
But a
depends
second
on where that
rotation
rig is and
untwists
why
me. We can also
it's
visualize this with a cube attached
its
to nearby
size more
walls by
conducive
ribbons.
in one of those
If we
fractal
rotate the
systems
cube
dealing
by
with more grease
360
to do it that
degrees,
way
the cube
than jet
itself is
fuel.
back to the starting point,
But
the
this one
ribbons have a
has
twist compared to how they
those
started.
proper models that
Amazingly, if we
describe
rotate
why
another
that is what it is.
360, not backwards but in the same direction, we get the whole
X,
system
Y, and
back to
Z,
the
it's not
original
going to be
state.
one state
Another thing to
of
notice
what this
is.
is.
That the cube
That's
can
something
rotate
we're
any
understanding
number of
here.
times with any number of
But
ribbons attached,
why
and
its
it never gets
orientation
tangled.
is a
So,
T number,
think of electrons as
the
being
combination
connected
here,
to all
the
other
flip
points in
it
the
made,
universe
the
by
system are
invisible
also
strands.
structural
One rotation
ones.
causes a twist
Fx,
to bring it
it's
back to
still
normal.
a
To
fractal,
get a little more
not the
technical,
universe,
the spinor wave
but
function has
still
a phase
within
that
from
changes with
0
orientation
and 1,
angle.
an
And a
expanding
360
principle
degree
that
rotation
is going to
pulls
say,
it out of
from
phase
here and here,
compared to the
this
starting point.
calculation
To get some insight into what
is going
spin
to
really
change
is,
something
think
here.
for a
We're
second
diverting
about
energy in
angular
this
momentum
direction
and
to
about
this direction
regular
we
or
want it to
linear
go.
momentum.
And
A
transistor.
particle's momentum is fundamentally connected to its position.
It doesn't
By
really need to
Newton's
be
theorem,
that. I know you want
invariance
to push
of
it
the laws
harder
of
and
motion
farther,
to
but you
changes
got to
in
really look
coordinate
at that.
location
1,
gives us the law of
2,
conservation of
3,
momentum.
0, 1,
For related
2,
reasons in quantum mechanics,
0,
position and
or
momentum
1,
are
2,
conjugate
0,
variables,
1,
meaning you can represent a
0,
particle
1
wave
type
function in terms of
situation
either of
that
these
goes
properties.
with the
And by Heisenberg's
entertainment
uncertainty
scale
principle,
for
increasing your knowledge of
Warhammers,
one means increasing the
300,000
unknowability
points
the
of
other.
that town model.
If position is the companion variable of momentum, what's
This
the
isn't
companion
just a
of
thought
angular
experiment. Some of
momentum?
these are useful
Well, it's angular position.
in that
In
system.
other words, the
Coefficients. I
orientation
do
of the
cut
particle.
coefficients
So,
all the
one way
time.
to think about the angular momentum of an
Logarithms
electron
as far
is
as
not from
forming
classical
those
rotation,
logarithms, but equally
rather from the fact that they have a
following them
rotational
out. Once I
degree of
get the
freedom,
bone works
which
done
leads
to it,
a
we
conserved
are
quantity
logging
associated with
today
that.
about
They have
information.
undefined orientations,
It's
but
good
perfectly defined
time to
angular
time on an
momentum.
increment of
Some
bi-monthly
physicists think
hit
that
that
spin
line,
is
not
more
that whole
physical than this.
sequence that does
Hans
that
Ohanian,
operation.
author of
We're
one of the most
going to be doing
used
lots of
quantum
different
textbooks,
fractals
has shown
that
you can
kind of
derive right
overlay
values of the electron spin angular momentum and magnetic moment
in
by
that
looking
system
at the energy and charge
that have
current
those
in the
moments.
so-called
Reluctance, you'll
Dirac
see in
field.
crew.
That's the quantum
Resistance
field
is what you'll
surrounding
have.
the Dirac spinor, aka
Anyway,
the
catch you in
electron.
the next one.